Good day, students. Welcome back. Today we are going to look at source coding. Under this source code, we are going to look at Huffman algorithm and Shannon algorithm. Let's go straight to how to get our Huffman codes. Now, looking at this question, look at the question we have here. I hope you are seeing it. It says apply Huffman procedure for the following message assembly with the probability 0.4, 0.2, 0.2, 0.1, and 0.1. And we have the symbols to be S1 to S5 because they are up to 5. 1, 2, 3, 4, 5. We are asked to find the Huffman codes and also find efficiency or variance. Okay, how do we get this Huffman code? We have steps and algorithm on how to get this. The first thing you have to do whenever you are given this symbol is to arrange the message in order of the decreasing probabilities. You go through the question given to us. Fortunate enough, our own is being arranged. We have 0.4 first, 0.2, 0.1, and 0.1. So it's already arranged. But assuming you are given the one that's not arranged, you have to arrange it first of all in decreasing probabilities. Then, after arranging it, you are going to combine the bottom. That is, from the bottom, you combine two elements to form a new entry with probabilities. When you sum this probability, you are going to get the sum of original probability or close to what you have up here. Then, the next thing is to assign code words. Assign 1 down and 0 up. You continue to combine until you are left with only 2 symbols. Okay, let's look at the question given to us here. We have that our symbol S1, S2, S3, S4, and S5. And we have our probability is 0.4, 0.2, 0.2, 0.1, and 0.1. It's already arranged in descending order. Now we'll start by combining these two. When I combine these two, 0.1 plus 0.1, I'll assign 1 here and I'll assign 2 here. When you add it, you are going to get 0.2. So we are going to take it up to where, if you like, put it here, but I decide to put it here to where I have my 0.2. So let me bring this one forward. I have my 0.4, I have my 0.2, and I have my 0.2. So I'm left with 0.4, 0.2, 0.2, 0.2. I'll combine these two again. And assign 1 here, down, and 0 up. When you add it, it's going to be 0.4. So it must go above 0.2. Remember, we are arranging descending order. Let me put it here to be 0.4. So I'm bringing down my 0.4 here and this 0.2. I'm bringing it out. Then when I combine these two again, I have my 1 and 0. Adding it, I'll get 0.6, so it must go up here. I have 0.6, 0.6, and I'm bringing down my 0.4. So assigning them again, you have 1 and you have 0. So when you add it up, it's 10. So we're not going there. So let's now get the code word. I've had my symbol, I have my probability, then my code word will now be, how do I get my code word? For S1, S2, S3, S4, S5. and my length, ni. Now let me go to S1. If you follow this S1 here, let's go to S1, follow S1. I hope you are seeing my hand. Follow this S1, follow this line here. You have 0, 0. So I have my code word with 0, 0. Let me go to my S2, follow my S2 up here, follow it up here, follow it up. When you are reading, you are going from back. So if I follow this S2 here, I have my 1, where is my S2, and 0. So I have my 1, 0. So if I follow my S3 up, follow it up, so I have my 1 and 1. So follow S4, follow S4 here. So what am I going to get? Where is my S4? It goes like this. It goes like this. This is my S4. It goes like this. So I'm going to have, and it goes up. I'm going to have 0, 1. I'll continue to go up, and 0. Look at it here. 0, 1, and 0. So I'm going to have 0, 1, 0. Then my S5, flowing it up again, you're going to have 0, 1, and 1. 0, 1, 1. Now how many code length word do I have here? I have 2 here, 2 here, 2 here, 3 here, 3 here. That means the minimum code word we have here is 2. Okay, let's look at Shannon algorithm. We are talking about Shannon algorithm. How do we get this Shannon algorithm? Okay, we're still doing the same thing. In Shannon algorithm, if you use Shannon algorithm to do this, we are still going to get the same answer. Now, if you are given a symbol, let's say that we are given a symbol 1 over 2, 1 over 4, 1 over 8, and 1 over 8. So let's assign it. First of all, this is S1, S2, S3, S4. So the thing is equally arranged. Okay, it's equally arranged. So let me go to another one that is not arranged. Assuming you are given a symbol like 0.3, 0.18, 0.35, 0.07, 0.1, and this is x1, x2, x3, x4, x5. If you look at what we have here, you find out that my x3 is the biggest. So the first I'm going to write is my x3. After writing my x3, which is 0.5, so this is my symbol. My probability is 0.35. Then we have the next one that is following is x1, which is 0.3. The next one that's following is x2, which is 0.18. The next one is x5, which is 0.1, and x4, which is 0.07. So let's look at our code word. Our code word, how do we get our code word and the length? Now, the same thing, we have already arranged this in descending order. You can see that it was arranged in descending order. Now, instead of joining the two together like Huffman, we are going to group these probabilities into two in such a way that the grouping will give us the sum of the one group or relatively close to it. Now I will start by grouping this. Let me group this together to be 1. Remember, we are putting 1 down, and this one to be 0. So that means whatever I have value here will be 1, 1, 1. My 3 will be 1, 0.18 will be 1, 0.07 will be 1. Why this one is 0? So I've done the first grouping. If you add this together, 0.3, add 0.3, yes, 0.18, and so on and so forth. It will be a little bit bigger than 0.35, but if you say let's join these two together and add the other one, this will be too big. We are going to get 0.65, which is far much bigger. We'll add 0.18, 0.1, and 0.17. So that is why we added this together. So the next thing I'm going to do is to group another one. Let me group this one together and call it 1. Then I'm grouping the other one together and call it 0. So this one now will now be 1, 1, 1. Why this one is 0? So I'm grouping again. Let me group this one together, call it 1, and call this one 0. So this is 1, 1 for these two. Now you can see that if I group this one together again, I'll be left with this one will be 1, while this one will be 0. That means if you have, look at it here, I have here 0, I have here 1, 0, I have here 1, 1, 0, I have here 1, 1, 1, 0, and I have here 1, 1, 1, 1. So the chord length I have here is 1, here is 2, here is 3, here is 4, here is 4. I say that is very simple. That's using Shannon method. Let me look for another example. Okay, let's look for another example. Okay, let's say that we are given this particular question. I hope you are seeing it. We are given this particular question. We are asked to find the Shannon-Fanon code for the following 6 messages with probability as indicated: S1 to be 0.36, S2 0.18, S3 0.18, S4 0.1, S5 0.09, and S6 0.07. Okay, in this aspect, you are still going to arrange it in descending order. But there's something we'll find out here. We have that S1, S2, S3, S4, S5, and S6. We have 0.36, 0.18, 0.18, 0.1, 0.09, and 0.07. Now, what am I going to do? I will pair this together. If you try to add these two together, it will be far much bigger than 0.36. So in that aspect, I'm going to pair this together and pair this one together. I'll pair this one together and pair this one together. So this one is now 1, 1, 1, 1, while this one is 0, which is 0, 0. Now, but you cannot just use the two together without splitting them. So coming to this place, I can now split it. So the first down one is 1, up one is 0. Is that clear? Now, I will continue again. I will pair this one together and this one together. So this is 1, 1, 1, while this one is 0. I'll pair this one together, 1, 1, this one is 0, and I'll pair this one together, 1, 0. So if you look at it, you can see the code words here. So the code word now, my code word will now be, for S1 I'm going to have 0 0. For S2 I'm going to have, now the difference in our Shannon is that when we are reading now, okay, let me just bring it out. You have 0 1 here, you have 1 0 here, you're going to have 1 1 1 1 0, you're going to have a 1 1 1 0 1 1 1 0, I'll have 1 1 1 1 1 1 1 1. So you can see that the length is 2 2 2 3 4 4. Now that's how to calculate your get your algorithm, Shannon algorithm. I did this summary of the flow chart, which you should know everything is arranged here. I say arrange source symbol in descending order of probabilities, match two of the lowest probability symbol into one subgroup, assign 0 and 1 to top and bottom branches respectively. You can write your own, but let everything that's supposed to be the step be written down. Thank you.